You're welcome. I'm Suresh from IARE College, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In today's class, we discuss about remote sensing. Now, what is remote sensing and what are types of remote sensing and how it is applicable in civil engineering and what we learn in today's class, we discuss here. So, before going to remote sensing, what is remote? Anything which is far or difficult to reach is called as a remote. Anything which is very far or difficult to reach is called remote. Obtaining the information without being physical contact. Obtaining the information of an object without being physical contact is called remote sensing. So today I am at Dundigal. I want data of some Dilshinagar or Hyderabad or Old City. I want extra data from Old City from Dundigal. So without going to Old City, directly from Dundigal, I can extract the information of data, whatever I required, without being in physical contact. So remote is far. So I am very far from Hyderabad at Dundigal, or I am in Hyderabad. I want data from Bangalore. Without going to Bangalore, I want to extract some information of Bangalore. So which is very far or remote. For example, I am in India. I want data of some other deserts or ocean or Antarctic region or Arctic Ocean. Some ocean is there. I want information of particular data source that can be obtained without being in physical contact. So remote means far away, and sensing means obtaining information which is very far. Okay. Remote sensing is the science and art of acquiring data, spectral, spatial, and temporal about objects, area, or phenomena without coming into physical contact, without being in physical contact with the object or phenomena under investigation. So, without being in physical contact. So, I want to find the crop or vegetation or capacity of reservoir or water levels in some lakes or oceans or rivers or various water bodies. Without being in physical contact, I can extract the volume or capacity of those particular data. Electromagnetic radiation, which is reflected or emitted from an object, is the usual source of remote sensing. So this, sorry, this remote sensing, for the remote sensing, the main source is electromagnetic radiation. It is also called as EMR radiation. So electromagnetic radiation is a main source which is reflected or emitted from an object, is a usual source of remote sensing data. A device to detect the electromagnetic radiation or radiation reflected or emitted from an object is called remote sensor or a sensor. So we detect. So I'll give you explain in next slide. Okay, just read this. Cameras are example of remote sensors. A vehicle to carry the sensors is called a platform. Aircraft or satellites are used as platforms. So now remote sensing means obtaining the information of an object without being very far. So see here, this is the solar energy. We have sun here or any source of energy which emits the electromagnetic radiation. In the presence of electromagnetic radiation, the energy which emitted from the sun reaches the object on the earth's surface. It may be a water body, desert, building, house, anything it may be. It passes from the atmosphere, it touches the ground surface. Some energy is emitted, reflected, or absorbed by the body, and after emitting, absorbing, scattering of the radiation, some amount of energy is reflected back to the atmosphere. So the energy which is reflected back to the atmosphere again is captured by a sensor. So the device to detect the electromagnetic radiation reflected or emitted from the object is called a remote sensor. So here satellite is a remote sensor which absorb the energy which have been emitted or reflected back from the target. This is the target. Okay, this is the target. So here sensor is a detective device which absorbs the emitted or reflected energy. So satellites are the have the sensors which can absorb or detect the energy which is emitted by the object. Okay, and platforms. These sensors are carried by some platforms like satellites. If you take an image of satellites, you can find wings of satellites. You can take a satellite like this, you have some wing like this. Yes. So here you have sensors. So a vehicle to carry the sensor in space is called a platform. There are aircraft or a satellite are used as platforms to carry the sensors. A vehicle to carry sensor is called a platform. So here platform may be an aeroplane or aircraft or airborne vehicle or a satellite. So in remote sensing, we are going to obtain the information without being physical contact with sensors. And these sensors are carried by platforms. So your platform is a satellite and satellite also have a sensor. So that sensor will absorb the energy or the will focus a particular location which data we want to extract or where you want to extract the information of particular location. Data versus information. Now what is data and what is information? Data can be any character or text, word, number, picture, sound or video. Data usually refers to raw data. Okay. Whereas information means the output. Okay. Once the data analyzed, it is considered as an information. Okay. So whatever the text, image, word, picture, sound, video, audio, whatever it is coming, is a data or it's a raw data. So once the data has been processed by visual image interpretation techniques or digital image interpretation techniques, then that data will called as an information. So data can be any character. It can be any character. So here the satellites which are in the space, they can absorb the data in terms of word, texture, sound, picture, video, anything. They can observe in any format. Data usually refers to raw data or unprocessed data. Aerial photographs, satellite images are the unprocessed or rough data. Once the data is analyzed, it is considered as information. So here the information, but information of your topography, contours, elevations, roads and buildings. These all come under your information. So if you want to find the information of forest area, hills, slopes, plain, plateaus, that can be extracted from the data after the analysis. There is information. So if you want to see the topography of Telangana, it can be done after analysis of the data. There is called information. So information will be a clear view. It may be topography or contours or elevations or roads or buildings. If you want to see high-tech city building in Telangana, it is also information from the data. It is also information from the data. Now we can see image here. Data collection by remote sensing. So here, remote sensing is generally of two types. Yeah. Remote sensing is generally of two types. One is passive remote sensing and another is active remote sensing. Now, what is passive remote sensing and what is an active remote sensing? So far, we are aware of remote. Remote means far away. Sensing is obtaining the information without being physical contact. So, as we are human being, we also have some sense organs like nose, tongue, ears, eyes, skin. These are sense organs which can sense or they can feel some information. So today I have in this room I have an AC, air condition. I can feel cold or cool because I have my skin is a sense organ for me. So without being contact with the air condition directly, I can feel it is cool in this particular room. Similarly, in remote sensing also, without touching the ground surface or the globe or the earth, we can extract information of various locations or various points. For this purpose, there are two types. One is active remote sensing and one is passive remote sensing. Now, what is active remote sensing and what is passive remote sensing? So, the information obtained in presence of sunlight is called passive remote sensing. So, for remote sensing, electromagnetic radiation is a main source. EMR is a main source to get the information or to collect the data of a particular location. Now, here solar energy is the free source which emits a lot of electromagnetic radiation. So the remote sensing which occur or which happen in presence of sunlight is called passive remote sensing. and the remote sensing which performed in absence of sunlight is called active remote sensing. So here we need the main source for remote sensing is electromagnetic radiation or electromagnetic spectrum is required for us. So here in electromagnetic spectrum, so sunlight is a free source which emits a lot of electromagnetic radiation. So so in presence of sunlight is called passive remote sensing. In absence of sunlight, that is, there is very clouds or sun is not properly visible, or we have some rainfall, huge rainfall. I want to perform remote sensing. In such weather is not supporting. In such case, I'll go for active remote sensing. So here I use a helium ion. This ion will emit the electromagnetic radiation, and this helps to send the signal to the ground and absorb the data in the sensor or satellite or aircraft. So here sometimes satellites itself emits the radiation and absorb the radiation in absence of sunlight. Sometimes satellite will absorb the radiation in presence of sunlight. So in presence of sunlight we are calling as passive remote sensing. In absence of sunlight we call active remote sensing. In absence of sunlight we can use an airborne vehicle. Okay, we can use airborne vehicle like this. So here we have a energy source which emits the radiation and absorbs the radiation. Okay, which has a sensor. Or you can get a satellite which emits the radiation, it absorbs the radiation. So like that, this is happening in the passive active remote sensing. That is, sunlight is absent. In case of passive remote sensing, there is no need of aircraft. Directly the sun emits the radiation. That radiation is reflected back to the sensors. Now, you can see an image here. So here the sun is the main source of energy which emits the radiation of electromagnetic spectrum or electromagnetic energy. Okay, continuously throughout the days. From years it is emitting the radiation. That energy is traveling from the atmosphere. Okay, this is atmosphere. And it touches the ground. So when the sunlight is traveling from the atmosphere touching the ground, this radiation falls in water body, on buildings, on plants, on towers, on trees, on ground surface also. So after touching the radiation to the target, these all are target on the earth, and after touching the target, some amount of energy is reflected back, emitted back, absorbed or scattered. Okay, so there are 4 stages. So whatever the radiation is emitting from the sunlight, that radiation is absorbed, emitted, scattered and reflected back to the source. And whatever the energy is reflected back after absorbing, the some energy is reflected back, emitted, scattered and absorbed. This energy is stored in the sensors. Again, this is sent back to the satellite and is stored in the platforms or platform is satellite here. This satellite has a sensor. So this sensor will capture the radiation whatever the target emitted back to the atmosphere, not the sun, target. So whatever targets emitted the radiation back is absorbed by the sensor, right? It is also an active remote sensing. You can see here. The sunlight is falling on trees or forest, water body, grass, bare soil, paved roads, build-up areas, many places. So whatever is emitted here, this all the targets are absorbing the energy, emitting the energy, reflecting back the energy. So you can see the red color here coming from the sunlight, and the brown color is going back to the satellite sensor. You can see this color. Here the sunlight. Yeah. Here you can see the energy is emitting back to the satellites from various targets from the earth. You can see here like this. Okay. This data is stored in the sensors of a satellite. Okay. This is how the remote sensing works in general. Now, electromagnetic radiation or spectrum. So here in sunlight, we have various energy radiations. So here we have in electromagnetic spectrum, there are many waves are there. In sunlight, the radiation is there. We can find spectral bands and we can find various types of rays are there in sunlight. So starting from cosmic, gamma, X-ray, UV, visible, IR, micro, radar, radio, and broadcast waves. This electromagnetic spectrum is visible only in the visible spectrum. So in visible spectrum, again we can see the VIBGR colors. This visible spectrum is between IR and UV rays. Okay, this visual spectrum is in between IR and UV rays. So here we can see 7 colors in the visible spectrum. These 7 colors can represent the object from the space, right? Electromagnetic property of objects. So electromagnetic energy and wavelength you can see here. Affecting factors: solar positions, atmosphere, meteorological season, ground condition, sensor characteristics, and sensor position. So these can be affected by these various factors. Remote sensing can be affected by various factors, and observation of by sensors. Okay, information extracted. So data processing by computer, image interpretation by humans, and applications. This remote sensing can be applicable for various fields like agriculture, forestry, geology, hydrology, okay, and oceanography, meteorological environment. So there are various sources where this remote sensing can be applicable broadly in civil engineering. Okay. Now, types of remote sensing. So we are aware of active remote sensing and passive remote sensing. Apart from these two, there are some types of remote sensing also there. That is visible and reflective infrared remote sensing. So the energy source used in the visible and reflected infrared IR infrared remote sensing is the sun. The sun radiates electromagnetic radiation with a peak wavelength of 0.5 meters. And thermal IR. When you see in this slide, we can see thermal IR, thermal IR, UV. Okay, this is the range here. The source of radiant energy used in thermal IR remote sensing is the object itself. So object itself is the source of remote sensing. Whereas thermal IR, you can take a black body. This black body is exposed to sunlight for more than 6 to 10 hours. So after that, the body will absorb the maximum energy and it emits energy back. There is a thermal infrared remote sensing. So here visible remote sensing is the energy source used in the visible and relative IR remote sensing is the sunlight. So sunlight emits radiation that is called visible remote sensing or reflected infrared remote sensing. Whereas thermal remote sensing is nothing but the source of radiant energy used in thermal infrared remote sensing is the object itself, because any object with a normal temperature limits electromagnetic radiation with a peak of about 10 meters. And microwave remote sensing. There are two types. One is active microwave remote sensing and passive microwave remote sensing. And active microwave remote sensing, we use a radar which can emit the electromagnetic radiation. Passive remote sensing measure naturally available energy, that is thermal infrared radiation emitted from an earth 24 hours per day, but solar reflected radiation only during the solar days. So here in active remote sensing, sensor emit radiation towards the target, reflect radiation emitted bands are detected and measured. So in active, the sensor will emit the radiation, it absorbs radiation. So sensor emits radiation towards the target. So here sensor is here, it emits radiation towards the target. Earth is a target. Reflected radiation is emitted band. In emitted bands are detected and measured. So whatever is emitted on the Earth's surface, these are get deflected back to the sensor. So these deflected bands are detected and measured in active remote sensing. Example, microwaves emitted from the source. Whereas in passive remote sensing, sunlight emits the radiation. Sunlight measure natural available energy, that is sunlight, thermal infrared radiation emitted from the earth 24 hours per day, but also solar radiation only during the solar days. So this is thermal and solar represented in your passive remote sensing, whereas sensors are present in your microwaves present in your active remote sensing. Now you can see this. So object and radiation sources. So I'm saying here reflectance, thermal radiation, microwave radiation, and back scattering coefficient radiation. Or we can say like this: visible IR micro remote sensing, thermal remote sensing, and microwave remote sensing. So visible or infrared remote sensing nothing but here sun emits the radiation, this energy touches the target and it is captured with the sensor. This is very easy technique. Sun always emits the radiation, target absorbs the radiation and some emitted back to the sensor. This is happening in the visible or IR remote sensing. Sun reflectance. An object. So here thermal IR remote sensing. Here the object itself emits the radiation back. Okay, it absorbs from the sun, but in absence of sun also it emits radiation because sun is continuously providing the heat energy to the black body. So we know the black body radiation. In summer season, the bitumen roads emit more amount of heat because it's black body, right? Like that. So the object emits radiation back to the sensor in the thermal remote sensing, thermal radiation or temporary estimative, and microwave my remote sensing. It is an object either it emits radiation back or it absorbs the radiation back. In micro we have two types: micro radiation, backscattering coefficient. So here we have an object and we have radar. So in microwave remote sensing, either the object reflect back the radiation or it emits and reflect back the radiation to the sensor. This is happening in your microwave remote sensing. Energy interaction with atmosphere. There are three ways in which total incident energy will interact with the atmosphere. So here we have a source of energy, sunlight. Sun is my source of energy. Okay, is agreed. So this sunlight will emit the energy to the target on the earth surface. So the target, whatever it is, it absorbs energy, it scatters energy, it reflects the energy, it refracted the energy, and whatever is remaining will send to the sensor in a satellite. Okay, it's sent back to sensor in a satellite. So there are three ways in which the total incident energy will interact with atmosphere. Okay, absorption, scattering, reflection, and reflection. Now let us see about in detail about absorption. Absorption is the process by which radiation energy is absorbed and converted into the other forms of energy, like forms of energy. Ozone, carbon dioxide, and water vapor are the three main atmospheric constituents that absorb the radiation. Okay, so radiation is nothing but UV rays. You can take ultraviolet rays or some other rays which are emitting from the sunlight. These are absorbed by the ozone, carbon dioxide, and water vapors. And there are three main atmospheric constituents that absorb the radiation. So ozone layer absorbs the harmful ultraviolet radiation. Just now I said this radiation from the sunlight. So carbon dioxide refers to the greenhouse gases. This is because it tends to absorb radiation strongly in the far infrared portions of the spectrum. And water vapor is the most absorbed vapor. Water vapor in the atmosphere absorbs much of the incoming long wave, the thermal, infrared, and short wave radiation. The range of water vapor in the lower atmosphere varies greatly from location to location and different time of the year. So there are the absorption. So we know that this ozone layer, the sun layer, water body or water vapor and the carbon dioxide are the main factors to absorb the radiation. Okay, so here ozone layer absorb the harmful ultraviolet radiation, whereas carbon dioxide absorbs the greenhouse gases, and the water vapor absorbs the atmospheric radiation or long thermal infrared waves and short micro radiations. Now scattering. Now what is scattering? So deviation of the or diffusion of the radiation by atmosphere particles is called scattering. Is unpredictable. Scattering is unpredictable diffusion of electromagnetic radiation by atmosphere particles. It occurs when the particles are large gas molecules present in the atmosphere. So when the radiation comes from sunlight, in atmosphere the different gases are there. So the electron radiation which interacts with the atmosphere will diffuse back in the atmosphere itself, or it touches the ground and diffuse and scatter back. Okay, when particles are large gas molecules present in atmosphere interact with with and cause EMR to be redirected from its original path. That's called scattering. The amount of scattering takes place depends on several factors, including the wavelength of the radiation, diameter of the particle of the, or gases, and distance of radiation traveling through the atmosphere. So it's unpredictable diffusion of radiation by atmospheric particles. It happens due to the large number of gas molecules present in the atmosphere. This is called scattering. And diffraction is a deflection of EMR radiation as it passes from one medium to other refractive index medium with a different refractive index. It's called reflection. So the deflection of radiation from one medium to other reflective medium with a difference of refractive index is called refraction. Okay, last is deflection. Difflection is a process where radiation bounce off. Deflection is nothing but it's falling on the target, it reflect back. Bounce off an object like the top of the cloud, the water body, or the terrestrial earth. Reflection differs from scattering. Scattering is diffusion, it will go like this. Whereas deflection is, it will go like this. So deflection is different from scattering in that the direction associated with the scattering is unpredictable, but in case of deflection it's predictable. So reflection only in one direction. Opposite direct we can take an angle like this. Yeah. Here you can see the various forms of deflection, emission, scattering, absorption, and reflection. Sensors, everything is here. So you can see the scattering of the energy source which emits from the sunlight. So the EMR source is the sunlight. The sunlight emits the radiation or it transmits the radiation to the target. Here the target will scatter the radiation, it absorbs the radiation, it emits the radiation or it reflects back the radiation based upon the property or the gas molecules present in the atmosphere. Okay friends, that's for today's class. We'll meet in next class tomorrow. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.